Hello, I didn't see you come in there. You guys are probably wondering what the hell I've been up to over the past couple months and why I haven't been really updating or putting a lot of videos online or really doing anything. You might remember a couple months ago I was pretty peeved and pissed off about the fact that Apple had deprecated OpenGL, essentially threatening any technologies that rely on it from running on Apple platforms. So what I did was, over the last 5 to 6 months, I have been learning how to use Vulkan and implementing a modular graphics core that can run OpenGL-like code on top of it, but can essentially be pulled out and integrated into any existing system that wants to use OpenGL-like rendering. What exactly does that mean? Well, what I'm saying is I am open sourcing that Vulkan core. I am taking the last 4 to 5 to 6 whatever it was, months of work that have been busting my ass to develop a Vulkan renderer, or I should say a Vulkan core, and I'm open sourcing that and releasing that this month. So that's basically what I've been up to. I've been integrating this core, trying to separate it out from the rest of my Verto Studio graphics engine, and I've been publishing that code on GitHub and testing it and making sure it works and providing an example which I will run real quick. What's important here is not really what's on the screen, but the technology that drives it. So let me explain. In order to do this kind of rendering or any kind of flexible rendering in a portable way, you needed to use OpenGL. If you wanted to run that on Apple, Linux, iOS, Windows, and so forth, the only real portable way to do that was OpenGL. I talked about that last time. OpenGL going away essentially made it so that there was no one way to do that without using Metal on Apple and OpenGL maybe on Windows, and then so forth and so forth. So what I did was I took everything that I saw being removed from OpenGL, all that flexibility, and I re-provided it in this Vulkan core. So all this work for doing all this crap on top of Vulkan that is OpenGL-like services, I have implemented, busted my ass, and then I'm out open sourcing that. And then as part of that work, I have an example renderer which kind of shows you how to do OpenGL dynamic pipeline-like stuff that you would expect an OpenGL-like renderer to be able to do. And I put that in an example renderer which I've included with the core distribution. And on top of that, I show you how to use that renderer to do something really simple, which is load a model, enable some switches, set up a vertex array object, so forth, render the thing, set up the shaders, and so forth. Basically everything that you would do in OpenGL, you would do in this. So most of the OpenGL features, not all of them, that are common to a lot of simple graphics applications, I've provided those via this core. So I'm really proud of this work. This is the first time I've open sourced something in like forever that I kind of consider worthwhile. I mean, you can see the size of this program that's actually considered like a user program of the core is very concise and simple, and it does all the work you'd expect that would be comparable to the size of like an OpenGL 3.0 program. So this is not a game engine. I'm not releasing something huge here, but I'm releasing all the work that you would need to do this kind of rendering. I'm open sourcing this work because I never want anyone to have to go through what I went through learning Vulkan, at least not from scratch. It's without a doubt one of the most complicated graphics APIs I've ever learned, and that's with 15 years of graphics programming experience. So that's my motivation for why I open sourced it. Let me quickly kind of segue into the Verto Studio architecture. For those of you that don't know, Verto Studio essentially is the name of my business, and it's also the name of my flagship application that my business stemmed from, which is Verto Studio 3D. Verto Studio 3D is a 3D modeling application that allows 3D artists to do basic modeling tasks like working with polygons and subdividing and texturing and so forth. Essentially what happened when I developed Verto Studio was I found myself developing a graphics library or a graphics engine called VGL. And VGL in the beginning was initially developed to only touch OpenGL. In other words, the only implementation of VGL was OpenGL. That was until this year up until this year when Apple deprecated OpenGL, I knew that I needed to get off of OpenGL as my only core implementation. So that's where Vulkan essentially came in. I decided to take all that work that OpenGL was providing for me and essentially pitching that over to the fence to my own Vulkan core, which does more of the heavy lifting, and then implements that on top of the lower level Vulkan graphics API. The gold box where I have the words VGL Vulkan core, that's the component that I'm open sourcing on GitHub. That's the component that essentially replaces most of the functionality lost by OpenGL. The important thing to take away from this is that the VGL graphics library, for the most part, is completely isolated from the core, and the application code, the code that's actually using my engine or graphics library, is completely isolated from whether or not you're using the Vulkan core or the OpenGL core. On Mac, this is a little bit more complicated than just saying I use Vulkan. Some of you guys watching might be like, well, I thought that there was no such thing as Vulkan for Apple, and that's true. Apple does not directly provide Vulkan as a graphics API. However, as I alluded towards in my past video on this topic, there is something out there called Molten VK, which is an open source implementation of the Vulkan graphics API on top of Metal. It's extremely thin, it's very fast, and essentially what that means is that I can target the Vulkan graphics API on Windows directly and on Mac indirectly through Molten VK and get the exact same results. This allows my code to essentially consider Vulkan the only low-level graphics target and allows me to not deal with crap about whether I'm on Mac or Windows or whether I have to touch Metal or not. So this is what the architecture looks like on Mac. It's a little bit more complex, but the end result's exactly the same. So we're going to end with just some quick examples of three separate application types that can run on the Verto Studio graphics library. We have the flagship application, Verto Studio 3D, which is the modeling program I talked about. That is written against VGL. And then we have an enterprise VR AR application, which is a city planning program that can run on the HoloLens or the HTC Vive in VR. And that program is written against Verto UI, which is my GUI, or I should say graphical user interface, modern implementation of buttons and widgets and stuff like that. And that runs on top of VGL. And yeah, so there's that. And then there's a video game, which I've made a couple of video games on top of the Verto Studio graphics library as well. So what I really want to kind of hit home here is that my motivation this year for doing all this work was to keep this really important component, the Verto Studio graphics library, viable to run on any platform in 2018, 2019, and going forward, so that I can develop as much application code as I want, whether it's for myself, paid client deliverables for contracting work, video games if I ever get the time ever again, and not worry about, or if someone else is using the Verto Studio graphics developer libraries, VGL and VUI, they should not have to worry about the implementation details of the graphics library underneath. They should just know that this is going to work anywhere. So you can kind of think of this as a more native, lightweight, faster alternative to game engines like Unity and Unreal that's more enterprise focused. So this is why I've been so damn busy for the last 5 to 6 months. I've really been working hard to get this thing going so that it's really viable for my business moving forward. And I just had to do it. And I'm really relieved that 90% of the work is out of the way. A few small little things with Vulkan I have to deal with moving forward, but most of the hard stuff's behind me. So if any of you guys have any interest in this particular component, or you want to develop or have an application developed on top of it for VR, AR, or mobile, you can feel free to contact me as well, either through my website below or either just via YouTube as well. So that's what I'm up to, guys. I know it's kind of dense. It's really hard to explain this in a way that wasn't too worded, but yeah, so thanks for watching as always, and I'll do my best to get another video tutorial out soon.